Chapter 28, Problem 30. This is one of my favorite problems in all of Physics 212. An electron is shot into region 1, which is exposed to a magnetic field going into the page as shown. It emerges from region 1, crosses a gap, and enters region 2, which is subjected to a magnetic field coming out of the page as shown. You need to figure out the total amount of time it took the electron to travel through region 1, across the gap, and through region 2. Step 1, let's break this into 3 time intervals. The time it takes to go from A to B, from B to C, and from C to D. Step 2, this is uniform circular motion found in both region 1 and region 2. Step 3 is asking the question, is this really uniform circular motion? It looks like it's circular motion, but is it uniform? And the answer is yes, because there's no work done on the electron by the magnetic force, because the magnetic force is everywhere perpendicular to the path of the electron as shown in this drawing. No work means no change in kinetic energy thanks to the work kinetic energy theorem. No change in kinetic energy means no change in velocity, which means uniform circular motion. Step number 4, let's take a look at the interval from A to B. The electron is moving in a circle under the influence of the magnetic force, which in this case is a centripetal force, so that's how we get the expression you see here. In step 5, I'm rewriting step 4 and simply replacing velocity. Step 6, theta is the angle between the velocity and the magnetic field vectors, which is everywhere 90 degrees in region 1. Make sure you can see that yourself. Step 7, I isolate t. Step 8, I note that the electron is actually traveling in a semicircle, which means it's taking half the period. Step 9, I take the exact same approach for region 2. Step 10, I now know the total amount of time the electron spends traveling through region 1 and region 2. Step 11, now it's time to figure out how much time the electron takes to jump the gap, to go from point B to point C. I'm going to fall back on kinematics, and in step 12, I'm isolating the variable t, in this case, the amount of time it takes to cross the gap. So if I'm going down this path of kinematics, I have to find VB, VC, and the acceleration. I'm remembering the earlier statement that says there's no work acting on the electron in region 1, which means no change in kinetic energy, which means no change in velocity. So my velocity at A is going to be the same as the electron's velocity at B. And down here you can see that I have to convert from electron volts to joules. I need joules in the numerator for dimensional consistency. Here's my conversion factor, and I do realize that a volt times a coulomb is in fact a joule. Step 15, now I need to figure out the electron's velocity at point C. I know my electron underwent an acceleration. The problem said a voltage was applied across the gap such that the electron would accelerate or speed up. This is a job for the energy analysis method. I get the kinetic energy at C isolated, and then in step 17, turn my attention to figuring out the change in electrostatic potential energy of the electron as it traveled from point B to point C. Step 18, I'm taking advantage of the definition of voltage. Step 19, I can now solve for the kinetic energy at point C. Once again, being careful to convert from electron volts to joules and storing this result in my calculator's memory location C. Step 21, now that I know my electron's kinetic energy at point C, I can use it to solve for the velocity at C. Step 22, I now know the velocity at C and the velocity at B. Now I'm turning my attention in step 23 to the acceleration that the electron underwent as it traveled across the gap. Step 24, I'm using Newton's second law and isolating for acceleration. Step 25, I'm remembering the relationship between the electric field and the change in voltage. That was a big deal, as it says from chapter 24. I'm ignoring the negative sign. I know the acceleration is going to be positive just because of how I have this voltage source hooked up and the fact that the problem said the electron was undergoing an acceleration. It was accelerating as it went from point B to point C. Step 26, there's my value for the acceleration. I'm storing that in calculator memory location E. Step 27, now I'm able to calculate the amount of time it took the electron to go from point B to point C. And step 28, I'm done. I add up the amount of time it took to go through region 1 and region 2 and across the gap. This is such a great problem because I used energy analysis method, force analysis method when I used Newton's second law, kinematics analysis method, uniform circular motion, and electrostatics.